Good day, everyone. I'm Natasha Heyman. I'm part of the Cohesive Marketing team, and I'm delighted to be your moderator for today's webinar, The Power of Linear Analytics with Maximo. Before we dive in, a few administrative and housekeeping notes. Note that all attendees are currently in listen-only mode. We encourage you to actively participate today by posting questions in the chat box, or you can use the Q&A bar as well. Please note that today's session will be recorded. You will receive a copy post-webinar, and we'll also be repurposing the recording for additional content on the Cohesive website, as well as our social platforms. So thank you for joining us today, and let me introduce you to today's speaker. Greg Hoyle, Cohesive Director of Transportation for the Americas, is a seasoned digital enterprise asset management solution architect, implementer, and project management. Greg began his career with Maximo in 1994 and has created, delivered, and managed solution implementations for many clients with a specific or a specialization in the transportation industry. He has implemented solutions with Amtrak, the New York Metropolitan Transportation Authority, Dallas Area Rapid Transit, and others over the past 18 years, and has significant experience and industry awareness to bring high levels of value to all our clients as they progress their journey through the definition and realization of an EAM strategy and solution set. As the transportation industry lead for Cohesive Americas, Greg defines the strategic industry direction and solution set for Cohesive to create and deliver full life cycle asset management. Today, Greg shares his expertise specifically on the power of linear analytics for or with IBM Maximo. Over to you, Greg.
Thank you, Natasha. Hopefully everyone can hear me okay. Natasha, if you can give me a thumbs up. Excellent. Good morning, good afternoon, good evening to wherever you are in the world. And it's very good to be talking to you today about Maximo and linear analytics. Linear analytics is a very strong, very powerful part of rail and track condition management and also linear asset management that I'd like to go through as part of our rail offering. A brief word about Cohesive, if you're not familiar with us in the past. Cohesive was formed from 9 previous companies 3.5 years ago, coming up to 4 years ago actually now, to specialize in filling out Bentley's overall vision for how to cover all of the asset lifecycle. Bentley systems were founded 40 years ago by a team of brothers, and their speciality is in creating infrastructure software, but not necessarily implementing solutions around that software. Cohesive was formed to fill in the gap. So if we talk about going from design through to commissioning, Bentley Systems has all of the software that you'll ever need to be able to do that work and create an information platform. The operate and maintain part, of course, what comes next, that is the specialization of Maximo as an EAM. And this is where the organizations that form Cohesive came from. So it directly complements what Bentley were and are doing in terms of infrastructure software management by extending that platform now into the operate and maintain phase, and of course feeding that information back around into design for a continuous improvement. In terms of what I'm going to be talking about today, linear analytics is used at many, 48 out of the 50 actually DOTs, with other aspects of the Bentley infrastructure model and platform. So there are many different products that Bentley has, far too many to mention, but linear analytics is used primarily at Amtrak, New York MTA, and also at others as well. They do complement Maximo implementations in the same organizations in some cases. And what I'm going to be also talking about here is the way that they could be integrated together to be able to provide a more complete understanding of track and rail condition and linear asset condition management, and directly impacting then our ability to create work orders and optimize the work event as we go through, responding to issues that we find or responding to, of course, capital project needs where we identify areas for improvement. And that may be through, of course, capital, or it may be through operating funding as necessary. But the point being that we want to be as effective as possible. We want to remove the impact, the unnecessary impact of intrusion onto the track. So we want to optimize our service delivery to the customer. That's what this is all about, creating that visibility of information so that we can provide a better service. So for compliance, you can see that we've got National Transit Database reports for US agencies and Maximo accelerators for rolling stock that complement Maximo and build on what Maximo has. And of course, we're using Bentley's capabilities and history and software solutions in being able to provide that more complete landscape and platform. But today, it's talking about specifically linear analytics with Maximo. So all of the other pieces aside, that's what we'll be concentrating on. In terms of where Bentley and Cohesive are around the world, specifically in transportation and transportation management, this is the world platform that we have. And one thing I want to highlight here is the areas in red, the circles that I've highlighted, is where linear analytics are used around the world. And of course, this is just a subset. So Amtrak are using it and have been since 1996. Washington Metro, for instance, Network Rail in the UK, and you can see down in Australia, ARTC, just some examples, and Canadian National being another large example. So when we get into linear analytics, it's a very specialist tool for track condition management. It directly feeds into asset management practices and a complete vision of how to manage the rail across its life cycle. Of course, we could talk further about asset investment planning and where does that information go once we understand the condition and the predictability of exactly what we're going to need to invest back in the track. That might be a subject for another webinar, but today we're going to be concentrating on exactly what linear analytics does and how Maximo fits into that vision. I wanted to start off today by talking about the business challenges that we have in the transportation industry from a big picture point of view. And again, this will help set the stage as to where linear analytics fits. So obviously we have challenges and we have opportunities because, of course, transportation is part of an infrastructure plan, usually for a city or maybe out in the middle of nowhere. But we still have to consider, of course, the environment that it's in, how we collect the information, the safety aspect of the rail infrastructure, and of course, workforce. How are we going to find people who are available in the areas that we need them to be? So we know that we have challenges where the black font, data access and quality, that is a major part of the kinds of issue that the infrastructure management environment and organization and industry has. How do we collect enough information to give us real insight and visibility into the condition of our assets and what we should do to improve them? All of the assets exist because they support operations. They don't exist for no other reason. And we, of course, need to maintain them relative to the design requirement that they were put in place for. So we're not necessarily taking the manufacturer's maintenance plan as the optimal way to manage it if we're not actually using the asset in its designed way to its major manufacturer's extent. What we might want to do is put it in context of how it's being used in the infrastructure complex environment that it's installed into. So if it's performing at 50%, we only want to maintain it to a level that actually is relative to that usage. If it's being overused, obviously that's a risk point and we want to think about that. Same thing occurs with the track. We need to think about the kind of load that we're putting on the track and how to manage it so that we don't have a failure or a degradation that we are not anticipating. In terms of opportunities, though, we have many. We have opportunities now for digital automation, simulation in 4 dimensions, so that we don't just have a 3-dimensional simulation, we actually have a simulation over time. We can talk about a virtual design and construction, so we can compare different scenarios together and see which one is more appropriate based on exactly what we are planning to do and what our future ridership looks like. We're looking for predictive decision support on assets, and this is where the Maximo combination comes in, because of course, if we're feeding information from Maximo based on the work order history of assets, we're bringing in condition information from the geometry reading on the rail, put the two together, and then we can actually figure out what that decision needs to be, whether that be construction, replacement, reinvestment, change of maintenance strategy, and so on. And of course, we want to have collaborative design and engineering combined with the insights that we get from the actual usage, the operational usage of that asset, so that we have that feedback loop back into optimizing design for the next stage of our progression as an organization. So that is the big picture review. Moving into what it means in reality, infrastructure management business needs are to review inspections, exceptions that create exceptions, which of course require then a plan for what are we going to do about those exceptions. Do we plan surfacing or other work that we have, like grinding, profile adjustment, whatever that might be? We need to prioritize where we work. One of the issues, for instance, with Maximo is that we would love to be able to group work together and deploy it, but we don't necessarily have visibility into how much other work might be happening in that area at that time without it being a fairly involved process. So if we have a simpler way of seeing what work are we needing to do in an area, how do we actually conform that gang or that group of people to go out and do the work in an area and fix as much as possible in that area with one visit, so that again we reduce impact to service provision and we increase the hit rate, if you will, of resolving defects and issues with the minimum amount of visits. Clearly we've made an improvement. We also need to actually use funding very wisely. If we're in an industry, of course, like we are with transportation, where it's primarily public funds, we need to use those funds as wisely as possible. And we need to make sure that we're getting the most out of our asset life cycle. We're also getting the most out of our work return. So we need to make sure that we have all of that response in terms of correct planning, correct operation, as optimized as possible along the track. Clearly, state of good repair is a common need. We need to make sure that we're maintaining the assets in the right way according to the funding profile that we had submitted in order to create the asset in the first place. That means we need root cause analysis. We need to understand what's happening with the asset. If we're looking at a dip in the rail, we want to make sure that, is that an issue with the culvert? Is that an issue with the track? Is it an issue with the ballast? Is it an issue with the load that we're putting on the track? We need to understand exactly what's happening so that we can correct it properly. Work effectiveness, again, is that combination of being able to put a strategy together as to how we deploy people to the track in the right way, at the right time, with the right tools, with the right time, with the right clearance, with the right safety profile for them to be able to do as much as they can in one visit. And then, of course, minimizing service disruptions, it all comes back to that. We need the actual client, the customer, the paying passenger, or the freight company to be able to have the appropriate level of service from the track. So from an infrastructure management point of view, this will give us visibility. This is one picture that I like to provide on the top right hand corner, is the number of different tracks that there may be and the complexity of modeling them. So if we ask ourselves how many different assets are there in that diagram, we need to actually do some serious thinking and planning in GIS probably to be able to delineate the number of assets that we have from point of switch to point of switch, if we're defining them that way. Otherwise, it could be from geographic boundary to boundary, or it could be ownership boundary to boundary. And of course, if we have different business units managing different asset types with different costing profiles, we may have different boundaries for different types of assets. It gets very complicated very quickly. Rolling stock is a little less, of course, complicated, but it still has complexities like configuration management and being able to assemble the assets in the right order, in the right way to make sure that we have good operation, safe operation of that vehicle. So when we're relating that and those business needs back to Maximo, we know that we have linear, for instance. We know that we have the ability to model linear assets in Maximo. We also know that we've got the ability to model condition analysis in terms of Maximo and MAS health. We also have, of course, the ability to manage safety related to the ability to maintain that service through health and safety and environmental. Configuration management is ACM. Transportation and the management of wheeled vehicles provides all the information that we need there. And of course, bringing the GIS information in allows us to show it in spatial. And then third-party management through service providers. So we've got everything we need, along with scheduler for capital planning, to be able to model everything around infrastructure management and linear management in Maximo. The thing that we don't have in Maximo is the detail to say exactly where we have dips in the rail, problems with the profile, and so on and so forth. If we bring all of that information into a meter in Maximo, that would give us visibility, but then of course we'd have to create the ability to define what that visibility means? How do we then provide that insight? And how do we relate it back to the underlying geometry and geology of the infrastructure? What's affecting that hotspot? So, as a way of introducing Maximo in this context, you'll see here that this is the typical Maximo screen for modeling a linear asset. In this case, we're looking at linear attribution. So we have the ability to define, for instance, speed, status, ties, or sleepers, depending on where you're from. The ballast type, all with linear attributes to be able to show along the track what is where and what are we doing about it, what kind of condition we have. And of course, at the bottom, you're looking at the features associated with the track, which could be a guardrail, could be something associated with the rail, could be multiple layers of different linear asset types, one on top of the other. So you've got the actual right of way, the track, the ballast, the overhead wire, and so on. All linear assets all need relating together to be able to see what's affecting what other type of asset. And then, of course, further down below, we've got the linear work that we've done against the asset. So we've got the accumulation of history, and that gives us a behavior profile. But it still doesn't give us the insight into exactly what's happening to improve or to address issues over time in the visible way where we can actually see that in a graphical manner. So when we're talking about work progress and history, we're obviously building that up based on the number of work orders that we've created in a particular location using the linear process within Maximo to be able to say, I'm working on this feature, this asset, this area, and so on. So we have all of that information in Maximo. Now, what happens though if we have a work order that crosses one of those boundaries that I was talking about before? That creates a bit of a challenge because, of course, we have the potential issue for work to begin and end on one asset and then start on another, but it's continuous across that boundary. How do we model that? How do we show what we've done? Maximo is very asset centric. Of course, it's got the multi-location, multi-asset table, but it can't necessarily visualize that. So again, we're looking at potentially strengths in the linear analytics tool to complement Maximo. And this isn't to replace it by any means. This is to feed information into Maximo so that it can be more effective. But it can also be much more effective for the user in terms of how we're addressing those issues from a linear point of view. So I wanted to introduce this diagram for the purpose of showing how the information relates. This is how the information underlying the products actually merges together. So we have Maximo, we have attributes against assets, we have activities of work, we have work plans, all related to linear assets. Of course, if we have GIS information or LiDAR, we've got the definition of the assets in a geographical format, and we have the attributes there that can flow backwards and forwards between the systems, one geographical, one asset management. Linear analytics allows us to visualize that with the track condition itself. So when we're looking at the geometry profile, ultrasonics, radar, whatever it might be, curvature, speed, there may be many, many different axes of information that we want to review alongside the track condition itself and the track weight and the track, let's say, insulated joints, the miter rail, whatever they may be. We can look at all of that information in one place and we can see the relationship where we have an issue that, of course, Maximo can then respond to with one of those work orders. Then we have history on both sides. We've got the history of the condition over time, and we've got the history of what we've done about that condition over time. That will give us the profile of now we can justify funding to change that profile, change the way that we address that track segment over time, maybe with a redesign, maybe with a change of maintenance practices, maybe with a change of operational utilization. There are many options, of course, in just making the data visible to us. So, as an introduction to what is linear analytics, it is a tool from Bentley that, of course, Cohesive is very expert at implementing alongside other implemented tools such as AssetWise, and it's part of the AssetWise brand of products. So its full name is AssetWise Linear Analytics. We call it linear analytics. It used to be called Optram many, many, many years ago before it was procured by Bentley, but the principle is the same. It looks at a graphical depiction of the track. So the track itself is the logical design, and that row, as you can see along the top of the diagram, the severity of issues that are shown against the progression of that track over time comes from inputs from geometry cars, ultrasonics, you name it, any other measurement device that's running along the track. So a Sperry car, for example. Any kind of linear asset can be reviewed and recorded. It doesn't necessarily have to be track. It could also be overhead catenary, or it could be wires associated with the track, or it could be the tunnel itself. So there are many ways to model, if you like, a linear asset and its condition as you're progressing through that linear asset. Down below, you can see obviously where we're looking at the profile of that track and where you've got specific issues such as surface left and right rolling standard deviation. Mathematics applies, of course, because we've got to determine exactly what is our normal profile and what profile we should meet, and then what are we actually seeing over time in terms of degradation on the track so that we know what to do next. So this is everything that linear analytics would show. It's a much more detail, of course, than it would be in Maximo and in meter readings. And of course, it already contains a visualization, so we don't have to create complex reports or other output to be able to show exactly what this means. Now the trick is to combine that with the work management side so that we actually see the connection between what we're seeing in track condition and what we're actually doing about it. And that's where we come to the next step. So where we have a work location highlighted clearly by a hotspot like we've got right now, we also see in blue the work events that were created in the past. And those work events can be, of course, related to the work orders that we have created in Maximo, and that would give us the connection between the two tools. So hovering over that work event should pop up a nice Maximo box, which tells us which work order on what date, covering what territory, and what, of course, was done, and allow for a link and a movement back into the detail in Maximo, and then, of course, back to the track chart here when we are looking to do some more work in linear analytics itself. So we have a view that's now combining both products together. Ideally, we would see that together in one actual image on the screen embedded into a Maximo frame so that we would have that be seamless movement backwards and forwards. In terms of then work planning, this is an example that I wanted to show here. We're looking at very specific things on the screen. So at the top, again, we've got the logical depiction of the track. You can see here we've got rail crossings, those vertical bars as they go through the green line. We're also looking at work events, as you can see in the middle of the screen, and that progresses by time. If you see the timeline on the left-hand side, we're moving up. Yes, it's a few years ago, but the principle is we're showing the actual progression of change in the track over time based on what we're doing to it. And that's what we want, is the visibility. So if you look at the top here, you can see the anomalies that we obviously have. And you can see, if you're following my cursor, we're looking at different surfacing plans that have been performed over time. So for instance, we've got one from 2017 and Q2, then Q3 and Q4. So if you follow the blue, green, and red lines, you can see this anomaly on the left-hand side here is clearly extremely bad in Q4. So we know we need to do some work. Whereas if we look at over on the right-hand side, you can see the survey at Q4 shows us the work that we have done through this work event, greatly improving the quality of that track at that rail crossing. So that's exactly what we want from linear analytics. We want to know that there's a problem. We want to know what to do about it. We want to know how to combine it with other work events. And we want to know that we've made a difference. And of course, we want to address the root cause underneath when we actually find out exactly what was causing that issue in the first place. So this over on the left-hand side here, this anomaly, this is probably too far away to combine with other work events, but it may be close enough to be able to address at least this hotspot here in the middle, which looks like it's proceeding beyond its good point. So we might need to take some preventive action there. But again, this leads back to how do we do good work while taking as little time on the track as possible? We need to have that visibility to say, what is a reasonable boundary for us to work in? Is it a mile? Is it half a mile? Depends on the gang that we're applying and how much actual time we've got from the operating company to say you've got access to the track. What can we actually achieve during that time? put that all together, and then we've got a series of work events to be able to address as many of these issues as possible, understand the root cause, get to the point of removing that issue at the root cause, and then of course applying that in an ongoing situation as optimally as possible with the people that we can apply to the work. So if we only have 4 hours access to the track, we better make sure that those 4 hours are extremely effective. And we get rid of as many of these anomalies as we can, primarily because, of course, we don't want to cause work to be delayed. We don't want to cause disruptions in service either, because this is going out of tolerance. But we also want to make best use of the track and the time that we have so that we can make improvements elsewhere. So that's what this linear analytics diagram is showing here, is the combination between work events, the improvements that we've made over time, and then, of course, the visual representation of that condition. We can actually see, though, as well, if we have a look here, the deteriorating track quality. So linear analytics doesn't just do a picture of a point in time. It can show, of course, a progression over time, like we saw in the last slide, but in this case, I'm showing it slightly differently. These are readings that are being taken on a frequent basis as each geometry run is done by the operating company. And this could be every 30 days, it could be every 2 months, it could be 6 months, depending on what the actual gauge of the track needs to be, or the class of the track even. That will determine the frequency of inspections. We need to get the information back into something that's showing us the actual movement of the track quality over time. This one is highlighted specifically because you can see from bottom to top, as the readings are progressing, you can see it's getting progressively worse and worse and worse. And then we get to that point again at the top of that red line where we have done the work to fix it, and then you can see we actually are in a much better place where we're getting no bad readings, except for a single blip. You can see right here in the red. That might be not systemic, though, of a problem as a deterioration. It may just be a one-off that we can fix, but we seem to have fixed the root cause with the that was causing this deterioration over time. So we're seeing everything that we can about the deteriorating nature of the track, but we want to be able to connect that to Maximo. So when we create a work order in Maximo, we can relate it directly back to this inspection point along the track, have all of the information flow into Maximo about exactly what it is that we're trying to address. We know that we need to address this hotspot. We know that we can only address that hotspot because, again, of distance over the track, but we need to be able then to define it from a root cause point of view. That will help us tell exactly what we need to fix. If we're, again, fixing a dip in the track, are we fixing a culvert? Are we fixing the ballast? Are we fixing a broken tie? What is it that's causing the issue? So we need to be able to give the information to the gang or the crew to be able to go there with all the tools that they need to do to fix the issue once and for all. Moving further along, this is something I just wanted to be able to show, because the actual profile of the track and the layout will clearly determine how well or badly it could be performing over time, depending on the load that we're putting on the track. So the segmentation you're seeing here at the curves level is showing us where we have curves of a differing radius, and of course the connection between a straight track and a curve. If we're having a very tight curve or a spiral or an actual change of radius as we go around a track to a tangential track, which is straight track, then that may be more load points, and therefore that may require greater design input, greater concentration on maintenance, of course, but it also might require us to think about, are we overloading that track if we're seeing too much deterioration and constant need for maintenance? So the segmentation here is just one example of the extra data that linear analytics can gather and show. For instance, Amtrak are using it to capture speed ratings against a track. And that would be determined based on, of course, the profile of the track and the curvature and the vertical alignment of the track. And of course, the distance to the next railroad crossing or the next station. Many things to think about, but they've got that all planned out, and being able to put that in linear analytics and being able to show it alongside the condition of the track will help us then determine, again, where do we do work? Minimal disruption. Do we do work entirely through a station to clear that station track completely? Or do we do work before the station and after the station and then do as much as we can with repeat visits. It depends on the context, and we need information to actually tell us exactly what that context is. When we get to a point now where we have done multiple visits to the track, as you can see here, we can have a look at the data associated with that visit and then turn it into something which is graphically useful to show us exactly what we should do. So linear analytics, again, can have a look at what we've done in terms of a construction event, and you can see the difference between the quality of the track before the construction event and after. But linear analytics, it doesn't stop there. It also shows a prediction. The prediction is moving forward in terms of what will happen if we do nothing. And this is where the actual track condition will go. And at some point, of course, it will hit a trigger point where we absolutely need to react. But we don't want to just react when it's got bad and provided a rough spot and provided a bad experience for the traveling public or the freight line or whatever the track might be used for. We want to get to a point where we are maintaining it over time so that it doesn't get bad, it doesn't cause an issue. It is a seamless, ongoing maintenance of the track so that it can perform at its optimum. So if we have a look at when we did the last construction date, and that was tamping, you can see the improvement that we made. Obviously, it didn't replace the rail, but we have a Maximo work order that we're connecting to be able to say that that occurred, and we have the history associated with that construction event. Next thing along the line would be the last survey date. So after we've done that construction, we do another survey. And that might be, again, on a regular basis based on inspections. But it will tell us what that last survey date indicates in terms of a deterioration rate for that track. And of course, we have a connection to the Maximo work order for that inspection. So we have the connection for the work that we've done against the track and also the inspections that we're doing, put the two together, and then we have that forward-looking vision of exactly what we are expecting that track to need over time. We can also then, of course, predict when the next construction event needs to happen. We might actually be able to get away with not having to do tamping for some period of time, but also we might think about, is tamping really the answer if it didn't fix the actual root cause of the issue before? So are we looking at tamping, or are we looking at a redesign? Are we looking at different rail weight, different ties, different clips, whatever it might be? Again, we've got to have the information, and then we relate it back to a Maximo work order with a plan to show us exactly what we need to do. And that, again, contributes to history. So linear analytics will give us an actual profile of what has happened, and then of course what will happen to give us the best decision making power to be able to say, how am I going to manage my linear asset? Ultimately, what we want to do is to be able to get to this point, which is I want to be able to see everything related to a track in one screen. I want to see the profile, the condition of the track. I want to see hotspots. I want to see areas that I need to address, but I want to see it in real world. I don't necessarily just want to look at it in lines on a chart. I want to be able to see how it's related to how I access that track. So on the bottom left-hand corner here, you're seeing an actual real-world review of where we are along that track so that I can see if I have access to go and fix the problem. And on the right-hand side, you're seeing, again, the broader context of how I access that track. So I know how to plan for that work to be done. I'm not necessarily relying on that to be done when people show up and then tell me that they can't access the track for one reason or another. This is intending to provide full visibility so that we have the ability now to do work in an efficient way and keep the trains running as well as they can. And of course, use the funding that's available to us in the best fashion possible. So that allows us to do more with less, and that is the underlying principle. So that is the reason for considering linear analytics alongside Maximo. We're trying to get to the point where we have seamless, integrated, optimized linear asset management. And like I say, that doesn't have to be track. It could also be catenary. It can also be wires along the track. It could be communications and signals. Whatever other thing might be affecting the infrastructure of moving a train through an environment. Clearly, we need the connectivity between linear analytics and Maximo itself to be able to capture that work history. And that's exactly what we have here with the two products combined. We have the information about exactly the anomaly that we're trying to address or have addressed. We know the root cause now as to what's causing that. We can capture that in Maximo for history, and we can show it in both places. This is where we actually have that information now that provides us the visibility and the wherewithal to be able to say, how am I going to now improve service? And that's the summary, Natasha.
Thank you, Greg. That was really very insightful. Based on conversation amongst our teams and clients, these are the most frequently asked questions that we would believe would add some value to today's webinar. Firstly, how does the geometry and other data get populated in linear analytics?
So what tends to happen on a rail operating company is that they will run a geometry car, whether that be dedicated or through
Mhm,
passenger enhancement, let's say, of a vehicle, and that will capture all the information in a database. That database then creates a CSV or other basic file of multiple hundreds of thousands of readings that would need to get harmonized and then populated into Maximo and into linear analytics, because we need the visibility on both sides. But for linear analytics itself, it simply brings in all that information from the geometry car, from the Sperry car, from the gauge, from the other inbound information sources, and applies that into its database. And therefore, we have the latest very, very small increments of information as we move through the track. Linear analytics is the best place for that information to stay, because of course it's at a very, very detailed level and will show us all of the anomalies at the detailed level. Again, what we then push to Maximo to say that we now have a work order to address an issue doesn't need to be the hundreds of thousands of readings. We just want it to be specific to where we need to do the work and what we're trying to address. And we can refer to linear analytics if we want to get into more detail. So it's just basically pulling the information from those track condition reading surveys that are usually performed either internally or by a third party, getting that information, putting it in linear analytics, summarizing it into Maximo.
The next question, I think you've basically answered quite a bit of the next question in numerous aspects of the presentation, but can you summarize how is linear analytics integrated to Maximo?
So there are a couple of different ways of saying this. Linear analytics, like I said, is basically the repository for all of the detailed information about the linear asset itself. How we integrate to Maximo is then a web service in terms of technical terms, making the information visible in both platforms, embedding it in a Maximo frame, for instance, making it completely seamless. From a data point of view, yes, we're taking the summary information from linear analytics and moving it into Maximo. We're also, though, moving the Maximo information of what the work has been, past tense, back into linear analytics, and also the work planning information, the capital project, the operating improvement that we would want to make into linear analytics, so that we have a forecast of what we're looking to achieve. So where it showed on that previous slide, the progression of the deterioration of the track, if
Mhm.
we have a work plan in Maximo, where, for instance, we're planning to retamp that area or redesign it, we should have a completely different profile based on the improvement that we're
Mm.
trying to make. So we'll see before and after, future, past in both systems.
The power of linear analytics plus Maximo. Um, the next question, how does linear analytics evaluate the track condition data?
Right. So linear analytics, of course, accumulates all this information. Like I say, hundreds of thousands of readings.
Mm.
What is possible in linear analytics and what is the actual need for the end user and for the business would be to analyze all of that information and then come up with a recommendation, come up with an understanding of exactly what that information is trying to tell you. And that is done through scripts. Those scripts are entirely configurable and easy to develop because they are in a common development language. Basically, if we're looking at an equivalent in Maximo, it would be a cron task running a script, running a function over time. So in the same way that Maximo creates work orders, let's say every day, every week, linear analytics would be analyzing that data whenever it gets a new feed and providing the next prediction, the next analysis of the track
The
condition.
predictive. Mm.
So what it's basically saying is evaluating the track condition is entirely up to the business organization. Obviously, we have a standard set of scripts for instance, track condition analysis. But let's say someone does want to put in speed limits on different sections of the track. That would be a script to be able to show that visibility on top of the track condition. So again, we could get the best of both worlds. We could get visibility of all those different profiles, all those different scenarios, all the different meanings behind that track condition, and then be able to see what's the underlying reason for it to be that way.
Can any other type of linear asset be modeled using linear analytics?
Yeah, so when we went through the presentation, obviously I did kind of precede
Mm-hmm.
this FAQ a little bit. We've got the ability, like I say, to record information as to what may be on the track itself and also on the ties, on anything related to the track. That could be the ballast as well. That could be the overhead wire, like I was saying. And the overhead wire, of course, deviates as it moves through the track. So we can keep a track of where those individual points are and how the track is actually affecting the quality of the overhead wire and vice versa, because there is a relationship between them. And of course, we need to optimize that based on the profile of the track that we're trying to achieve and the speed through that territory. So if we want to achieve a certain speed over a curve, we've got to configure the track and the overhead wire and everything around it to support that service. And that's exactly what linear analytics is trying to do. So any linear information around the track, anything else that could
Mm-hmm.
affect the track performance or the service performance is in linear analytics.
Perfect. And I think we have one last time for one more question. Can world graphics or representation be associated with the linear infrastructure and linear analytics? Sorry, that
Yeah,
was a
so
big question.
all good. So when I showed the previous slide, for instance, you saw the real world
Yeah.
definition as we're moving along the track, and we're seeing the
Mm-hmm.
context of the track as it's moving through an area. So it may be heavily wooded, may be difficult to get to. It's on a bridge, it's in a culvert, it's in a tunnel. But we need to know that before we start trying to issue people out to do work. I've actually got an example here of the kind of information that can be brought into linear analytics by the fact that we have got a detailed real world scan. So if this is real data that we're bringing in as a picture, as a fold, if you like, of the track from its simple two-dimensional point of view and laying it out, then we get all of the detail about exactly what components may be broken, what we need to do to the track, how the overhead wire again is relating to the track alignment. Um, are we at a point where we know everything about the track that needs to be focused on? And of course, we can use advanced modeling as well to be able to try and find those anomalies so we're not just endlessly clawing through multiple hundreds of thousands of events. We can see opportunities for improvement by looking at the anomaly, looking at the exception, and then we get a good picture of the track in real world view in context of how we would get to work on it, but we also get the detail of exactly what we need to do to the track.
Thank you. Thanks also for the proper example here. I think we can wrap that up for today. Greg, thank you really for the input, the insight, and the effort for this presentation. If you have any additional questions, please feel free to reach out to Greg via email, mobile, or even on LinkedIn if you have any questions. But until the next time, thank you, Greg, for the presentation.
Thanks all. I hope it was useful.
Definitely.